Hello, we are going to present our math project, and our team is composed by Javier, Maite, and me, and our problem is number 2.
The function is x squared minus 3x plus 2 over x squared minus 1. Then to obtain the domain or the restrictions, you only have to isolate x, that is here positive 1 and negative 1. To know the x-intercept, you only have to equal the function to 0, and it will be x is equal to 1. Then to obtain the y-intercept, you only have to replace the value of x as 0, and it is y is equal to negative 2. To know the symmetry, you only have to see if the function is equal to the function of negative x, or that function of negative x is equal to negative function of x. In this case, there is no symmetry.
In order to find if our function had a gap, we had to calculate the restriction and substitute it in our function. After that, we factorize it and simplify it. Finally, we substituted the x for its value, which is 1, in the function x minus 2 over x plus 1, and we found that the gap will be in the point 1, minus 1 half. To find the vertical asymptote, we had to calculate our restriction again and substitute it in the function in order to have 8 over 0. We found that the vertical asymptote was x equal minus 1. Starting at this, we calculated the closest values to x from the left and from the right, and we substituted with the function to find the limit's behavior. To find the horizontal asymptote of this rational function, we had to divide the numerator and denominator by the highest power of the denominator. Then, we simplify it and substituted the x to infinites, and we found that the horizontal asymptote is y equals 1. To get the first derivative of the function, first we use quotient rule. Then, we solve it and simplify it to get 3x squared minus 6x plus 3 over x squared minus 1 to the square. After that, we factorize the function and simplify it again. So, the result of the first derivative is equal to 3 over x plus 1 to the square.
The first derivative is f prime of x is equal to 3 over x plus 1, all of this at the square, the denominator only. The ID test will be with minus 2, minus 1, and 0. We will compare with minus 2 and 0 because in minus 1 we have an asymptote. Be a positive 3. So we have positive and not have critical points or near nor maximum or minimum points. Intervals. Decreasing is equal to minus to infinitive. So will be minus comma infinitive. The increasing will be minus infinity comma minus 1. To know the second derivative of f of x is equal to x at the square minus 3x plus 2, all of this over x squared minus 1, we need to first to know the first derivative, which is 3, all of this, 3 over x minus 1, all of this at the square. So the derivative will start like that. F of f2 prime x is equal to 3, and the denominator gets at the numerator at the power of minus 2. Therefore, we apply power rule, which is to get down the minus 2 and will be 3 multiplied by minus 2, and then the result of this multiplied by x minus 1 at the power of minus 3. Therefore, the x minus 1 at the power of minus 3 will be get to the denominator as x minus 1 at the power of 3. So the result will be of f2 prime of x is equal to minus 6 over x minus 1 at the power of 3. To know the concavity will be the test by the second derivative. So we'll have the values of minus 2, minus 1, and 0. We will compare with minus 2 and 0. Therefore, we need to substitute minus 2 in x in the second derivative. So the result of this will be a positive parabola. So it will be upwards. When we substitute 0 in x in the second derivative, it will be minus 6, sorry. And therefore, this will be a negative parabola. So this will be downwards. So happy face and negative and sad face.